All right. So this is Takuya from ARM, which is a chip company, but I'm not going to talk about hardware optimization or something in this talk, unfortunately. Alternatively, I'm going to talk the recommender systems. I'm going to introduce a package which allows you to easily build a recommendation systems by using Julia. So you can use the package like this, and also we have a GitHub repo, so you can access to it. But first of all, I'm going to ask you how many of you guys actually know at least one recommendation technique? Okay, some of them know about it. Good. Hope this talk is not that interesting, you know. All right, so let me start this very simple type or mutable type event, because in the context of recommender systems, the basic is in the user item interaction. So when I talk about the data for recommender systems, the important fact is we have to somehow represent who interacted with what and how. So the how means it can be purchase or click or rating, stuff like that. But basically, the data in the context of recommender systems can be represented as a pair of user and item and its value. So our package provides this interface. And on top of that, we do provide a data accessor which bundles the series of events, because the recommender system stands on the series of user item interactions. And obviously, you can create an array of events, and you can bundle that into the data accessor. Or you can explicitly create a user item matrix which represents the user item interactions in the matrix format, and it can be converted to data accessors. But anyway, any different types of recommender systems implemented in the package, you can easily pass your own data to the recommenders by using the accessor. And once data passed the recommender systems, the only thing you have to do is just to call the two different functions. One's build and another one's recommend. Once you call them, the recommender systems or recommendation model will be created based on the data, historical data, and recommendation will be made to the single customer or user. In terms of the algorithm, we do support multiple fundamental recommendation techniques internally. And the basic one is called the deterministic non-personalized recommender, which is super important in the context of recommender systems. Because when you go to Amazon without logging into your account, you will be able to see some deterministic recommendation. Here's a list of some most popular items, or here's a list of some discounted items. The basic is really important for the recommender system. So we do support multiple basic recommenders. And if you want to do more, we can calculate, for example, cosine similarity between users or items, so that we can estimate how much this user is similar to other customers. Based on that information, we can make more and more meaningful recommendation to them. Or you can do much more like the latent factor-based matrix factorization techniques for recommendation. So if you heard this morning's keynote session, as she mentioned about the low rank approximation, this is more like that. So you can apply the SVD or matrix factorization based on the stochastic gradient optimization. It is possible in our package. And you can also do the evaluation, like the cross-validation, by using a wide variety of recommendation evaluation metrics for recommender systems. And the good thing of the combination of recommender systems and the Julia is basically in performance and effectiveness for or syntax itself for vectors and matrices. Because that I explained before, user item interaction and matrix representation plays a really important role in the context of recommender systems. On that point, the writing recommender systems in Julia is more like a future as a developer of the recommender systems. And important fact I want to emphasize here is that recommender system is not only for machine learning. So of course, machine learning is a powerful tool, but not only that. On that point, Julia has a bunch of different tools in terms of mathematical field. So we can incorporate those kind of tools to make your own custom recommender. That is a good thing. One arguable thing is more in the application side. So, in the real-world recommender systems, we need to overcome large volume of data or continuously data streaming scenario, like the user item interaction is coming in every second or something like that. How to overcome the situation. And I do not have a clear solution here, but I hope I can get more and more insights throughout this JuliaCon sessions from the practical perspective. And I try to make this package as much as simple because, like I said, the customization is really important in the context of recommender systems. So, by the way, this is the online course is very useful if you are interested in recommender systems. And so basically, our package supports every single very simple components introduced in this online course, evaluation matrix or recommender techniques or non-personalized ones. But we do provide a way to customize the recommender systems because, like I said, we provide a different, the interfaces so that you can easily expand the recommendation capability on top of the interface, like data accessor or recommender or build function or recommend function. So, for example, if you use the low-rank approx package, which is coming from Julia Matrix's organization, you can put, you can actually create a new type, recommender type called partial QR, for example, which depends on the recommender package, base recommender package. On top of that, you can simply add some hyperparameters or model parameters in it, and you can simply initialize it on top of that. And the only thing you have to implement here is just how to build a recommender from the data came from the data accessor, or how to make prediction to your target recommendation target user. You can simply write some couple of different code, and you can just make recommendation on top of that. And originally, I tried to replace this slide by using the low-rank models library that I introduced in the last keynote session, but unfortunately, I didn't, it didn't succeed actually. So, but literally, you can create your custom recommender in an arbitrary way by using the interfaces. All right, so that's pretty much everything. Thank you for listening.
Okay. Questions for Takuya? So please feel free to ask questions. Okay. So how do you actually test your system? So you build a system.
Yeah.
So how do you test actually?
Well, it's more like the experimental one at this moment because so I just applied this method, this package itself to some commonly used data set, public data set in the field.
Still, already we have some recommender systems actually.
Mm-hmm.
So is there any features that you add or whatever actually? How do you compare your system with the existing systems?
Well, in my experience, recommendation, the comparison between different recommender systems comes from more like, the interface, right? So the key characteristics of this solution is in the more like the interface side. So we do provide a unified interface in the Julia context. So that we can flexibly customize our own recommender on top of the interface. So that's the part I want to emphasize if you talk about some comparison between different tools in the context of recommender systems.
Okay, then thanks.
So for the collaborative filtering part, like people these days are also trying to use some neural networks. So if I were to use maybe Flux API here, how do I do it? Or is it possible?
Oh, you mean you want to use neural networks?
Just on a simple, just create a very simple 1% farm,
Mhm.
some very simple neural network layer to do this, to basically factorize the matrix.
Mm-hmm.
Is it?
Oh, yeah. In the field of recommender systems, there are many different types of collaborative filtering techniques, and some of them are actually using more like probabilistic approach, or other one is more like the neural network approach. So obviously you can do that. And as long as the package is in the Julia community, that should be fit to this interface, right?
Any questions? No? Okay. Then thanks again to
Thank you.
This is the end of the session. We are in time. So I think Julia, organizer, should be happy.